it comes to the last question for this week, that is question number 5. So basically this question is about a Doppler effect. Let us first understand the situation or the question. So we have a toy with siren on, is approaching a wall at a speed of 2.5 meter per second. So this is the velocity for the toy. Okay, so if we draw the case, we have a toy. Okay, we have a toy with the siren on. So our toy here is basically the source of the sound. Then this is approaching. Okay, this toy is approaching a wall. So this is the equation given. It is if we compare, okay, the siren produce the sound wave of this equation, and this is basically the equation of a wave. Okay, we have to always compare our equation with the general one. So this is the general equation for progressive wave. It's y is equal to a sine omega t. So we have minus, it's minus kx. Okay, so we have to always compare our general equation for this wave, the sound wave. So that is, our general equation is y is equal to a sine omega t minus kx. So our value of a is equal to this value. Our value of omega is basically this value multiplied with this value, because we have the bracket here. And our value of k is this value 0.5 pi times the value of 6.4. Now we can answer the first question. We need to calculate the speed and the frequency of the sound wave. The equation for the speed is v is equal to f lambda, but we don't have frequency, meaning that we need to find the frequency first. So the frequency can be acquired from the equation of omega, that is 2 pi f. And we have known the equation or the numbers or the value of omega is 0.5 pi times 2200 is equal to 2 pi f. And from here you can have your frequency as 550 hertz. Then we have to also find our lambda. And lambda can be acquired from the equation of k, from the equation k is equal to 2 pi over lambda. Then we make the substitution. Our k is 0.5 pi times 6.4 is equal to 2 pi over lambda. Then your lambda is supposed to be 0.625 meter. And only after that we can find our velocity. Okay, so we go back to this equation. Then we can have our velocity is equal to f is 550, lambda is 0.625. Then your velocity is supposed to be 343.75 meter per second. And the second question is to find the frequency detected by the detector. So it says here in the question, a detector is fixed on the ground behind the source of sound to observe any frequency changes. Okay, so basically this is our source of sound, and we may imagine this is the ground and this is the detector. Okay, here is the detector. It's on the ground. So here is the detector. So remember, the sound is reflected. Okay, the sound wave is reflected. So in this case, we have for Doppler effect, the general equation is f frequency heard by the observer is v plus minus vo over v plus minus vs f source. So in this case, we have stationary observer. So VO is equal to 0. So who is the observer in our case? That is who that can observe the frequency changes. So our VO is equal to 0. As the case or as the toy is approaching, meaning that our F naught is increasing, the denominator is supposed to be small, so it is negative Vs Fs. So we are going to apply this equation. V in this case is the equation that we have got in the first question. So it's 343.75 divided by 343.75 minus 2.5. Vs is given and the frequency is 550 calculated in the first question. Then finally you'll have your frequency as 554.03 Hertz. So that's the answer.